Okay, now we're still on Mpumalanga. Let me look at this one. So this one is an easy mark, 2.1. This is what you are given. This is one of my favorite question when it has to do with first principle, especially also the derivatives. So 2.1, you are given f at x and they want you to determine f prime from the first principle. I'm sorry. So now let's go and work on this one. Okay, so I'm just gonna try and rewrite what I'm given there, and then I'll definitely work on that question using the first principle. Okay, let's just not waste any time and work on that. So this is question 2, and what are we given on question 2? Uh, I'm given f at x to be minus 2x squared plus 1. So I'm going to give you guys a very special exam tip here. So when you have this type of a question, first thing first, and they want us to, okay, this is 2.1. They want us to differentiate this using the first principle. Before you do that, differentiate using the rules. We know that the rule says that if I have x to the n, the derivative of that guy, it will be the n comes in front of x, and then we subtract 1 on top. So I'm going to use the rule and differentiate minus 2 x squared plus 1. So the 2 comes this side to multiply with that 2, then we subtract 1 on top. The derivative of 1, since it's a constant, it's 0. So the answer is minus 4x. So when you use the first principle, you need to get your answer as minus 4. Okay, let's write the formula down for first principle. F at x is equals to the limit sh approaches 0. And then we need to have f at x plus h, and then we subtract f at x. Okay, everything is divided by h. So that is the limit. So this tells you that the first thing that you need to do, we need f at x plus h. So on the equation, where there's x, I'm going to substitute x plus h. And then let's work on that. So this will be minus 2 into the x plus h into the x plus h. We're expanding the bracket. We still have that plus 1. And this will be minus 2 into, use the FOIL method. First thing first, let's take the first x, multiply the second bracket with that x, which will give us x squared plus xh. Then let's do the same with h. We multiply the second bracket with h. This gives us xh plus h squared. Close the bracket, plus 1. Do we have the like terms? Yes, we do have the like terms. So this is minus 2 into x squared, xh plus xh. Those two are the like terms. Let's add the two terms and say this is my 2xh. Then we're going to add h squared. What's next? This is plus 1. Eh? What's next? We multiply out the bracket by that negative 2. So this will be negative 2x squared minus 4xh minus h squared plus 1. That is my f at x, ladies and gents. I need to take f at x, substitute it on that limit. Remember we said f prime at x, it's equals to the limit as h approaches 0, and then f at x, we subtract, okay, it's x at x, f at x plus h, we subtract f at x, and then everything divided by h. Let's do that. Let's work on that part. Okay, so this will be the limit as h approaches 0. My f at x plus h is this guy. My f at x plus h, that is what we need to substitute. So this will be negative 2x squared minus 4xh minus h squared plus 1. You subtract f at x. Please make sure that when you subtract f at x, put it inside the bracket. So this will be minus inside the bracket. F at x is minus 2x squared plus 1. So this will be minus 2x squared plus 1. Okay, so everything now is going to be divided by 1, by h. So what I need you to do is to multiply out the bracket by that negative. So this will be negative 2x squared minus 4xh minus h squared plus 1 minus plus 2x squared minus 1 when we multiply out the bracket by negative. So I still remember on the lesson we talked about that. Whatever your f at x, it will be cancelled. Everything that was your f at x. So look at this. The 2x squared will be cancelled by the minus 2x squared, and then the minus 1 will be cancelled by plus 1. So exam tip is that f at x will be cancelled by something there on the other side. Okay, it's fine. Let's work on this. I'm just going to try and rewrite the equation down and see what we have so far. So we are left with the limit as h approaches 0 minus 4xh minus h squared. Everything is divided by h. Can we take the common factor out? Yes, we can take h because we can't do the direct substitution. The aim is to get rid of that h in the denominator, because if we substitute that h as 0, anything divided by 0, undefined. So this will be h. I'm left with minus 4x minus h. I think you guys realize that when I teach, I don't like to go into too much details because some of the things, they just straightforward. Né? So the h cancels. This leaves me with the limit as h approaches 0 minus 4x minus h divide, the h cancel with that. So now that this thing is simplified, that's when you can do the substitution. Please, when you sub in 0, you drop the limit, then this will be minus 4x minus into 0. Therefore, the answer is that negative 4x, the one that I told you about, negative 4x. So this is the derivative using the first principle. I hope you still remember that part, and I hope you are happy with that. So let me move to the next one. Okay. Next question. Okay, now we need to determine the derivative. So we have f at x. Now we need to determine the derivative using the rules. So I'll rewrite the f at x and find the derivative. So now we're going to work on 2.2.1. Okay, let me write that down. So 2.2.1, my f at x, it's equals to 1 over 2x squared minus 5 x to the power minus 1. Okay, so from this equation, I'm going to say that I need to find the derivative, right? So I'm going to find the derivative using the rules. So this will be 2 multiplied by, so my f prime at x will be f prime at x, this will be equals to 2 multiplied by 1 over 2x to the power 2 minus 1, then minus into minus 1 times 5 to the power x minus 1 minus 1. So we just using the rule that says the n comes in front of x and then we subtract 1 on top. This is exactly what I did. I dropped the exponent, multiply that exponent with the coefficient of x. then you subtract 1 on the exponent. So therefore, what is the final answer? F at x would be the 2 cancel, I'm left with x, and then this is plus 5. Any number to the power, this will be x to the power minus 2. Then this is your derivative. Let's look at what we have on the next one. So this is very special. Dx, I'll explain. Let's rewrite that question. Then I'll definitely explain how that works, okay? I'll definitely explain how that works. Okay, so now on that 2.2, I think this is question 2.2.2. Okay, so on that 2.2.2, I'll explain why the x is very special. So this is given as negative 2x squared plus. Okay, so when I look at this question, please do not, you see, when it's like this, it's not easy for you to differentiate it, right? You need to try and work it out, engineer the question, work on it. So when you are working on it, why I'm saying this is special, you keep the dx. You'll only drop the dx when you start differentiating. So let's keep the dx, and when I keep the dx, this will be, I need to separate the fraction. Remember, in maths, if I have a plus b, everything divided by c, I can just say this is a over c plus b over c. This is the rule I'm going to use now. This is minus 2x squared over x squared plus, and then let's talk about the square root. If I have n the root of 4, let's not say the root of 4, but the root of x to the power m, this can be written as the exponent inside the square root comes on top and the one outside comes on bottom. Okay, so I can say this is over n. This tells you that when I have this type of question, I can write the top part, remember it's to the power 1. So this will be x, the 1 comes on top, the 4 on bottom, and this is divided by that x squared. Okay, I still have fractions now. Let me work this thing out. Look at this. The x squared here and the x squared cancels. This leaves me with what? This leaves me with 2 there. And then this one, the base are the same. We are dividing the same base. What do you do to the exponent? You take the 1 on top, you subtract the 1 on bottom. So this is same as 4 over 2. It's like saying 1 minus 4, which is negative. What is this? Am I doing this right? It's 1 over 4 minus 2. Then this will be 4 over 2, which is minus 8 plus 1, which gives us minus 7. So this is x to the power minus 7 over 4. Remember, on your side, you don't have to be stressed because you have a calculator. You can just say 1 over 4 minus 2. Right. So this now becomes the x into, we said the x squared cancel, this leaves me with 2. Then this will be plus x to the power negative 7 over 4. I just want to write this right. So this will be x to the power 1 minus 7 over 4. Then you see now the question is simplified well. Now you can find the derivative, you drop the x. Therefore, the derivative will be, the derivative of minus 2 is 0. Then the derivative of x to the power minus 7 over 4, we drop the 7 over 4. We multiply that with the coefficient of x, which is just 1. Then this will be x to the power minus 7 over 4. Then you subtract 1. Right, you can also say this is equal to minus 7 over 4, then x to the power. If I have minus 7 over 4 and I subtract 1, this is 4 over 4. with the top part give me minus 11 over 4. So the answer is x to the power minus 11 over 4. So this is your answer. You can just leave it like that, or you can choose to write that as a positive exponent. So when I say positive exponent, you can write this answer in this way and say this is minus 7 over 4x to the power 1 to the power 11 over 4. But if you don't understand what is going on, just stick to that solution. Okay. All right. Oh, that was the last one. Okay, I guess for this one, this is where everything. This is where we're gonna stop for this one. Okay,